Okay, now we're going to be working with contextual situations or word problems, and we are going to be looking at something called the following object model and the vertical motion model. Now, the following object model is when you have an object that you're just dropping or an object that is just falling from a specific height. When that object falls, its speed continues to increase, so the height from the ground decreases at a faster and a faster rate. Now, ignoring air resistance, your equation and function notation for the falling object model would be in the format of h of t is equal to negative 16 t squared plus c, where t is your time in seconds, and c is your initial height, so where it starts off at, and that's in feet. And the negative 16 is actually the force of gravity. And then the vertical motion model is when you have an object that is being projected into the air. So maybe you throw your object up in the air, or you slingshot your object up in the air. That would be considered the vertical motion model. And this equation would be in function notation, h of t is equal to negative 16t squared plus v times t plus c. All the variables are the same except v is your initial upward velocity in feet per second. All right, let's get started. In your problems, you do need to determine what model we are using. Are we using falling object or vertical motion? An acorn drops from a tree branch 70 feet above the ground. And then in this problem, we'll round to the nearest hundredth if necessary at any point. Now, what equation represents the situation? Now, for this one, we're just taking our acorn, and it is just dropping, so there's no upward velocity. This is the falling object model. So my equation would be h of t is equal to a negative 16t squared plus my initial height. It started off at 70 feet. It says, what direction is this parabola opening? Well, since my a value is negative 16, it's a negative value. This is opening down. The path that what we're really graphing here is the height of your function. And so here we start at 70 feet, and the height's going to just slowly decrease, and then it's going to get faster and faster until it hits the ground. So it's kind of half of a parabola here, and let me draw that a little bit better. We're really, with the falling object model, we really just have half of a parabola. So it starts here and goes down faster and faster and faster like this till it hits the ground. Now it says at what time does the acorn hit the ground? So what we're going to do is for the height in my function, the ground is at a height of 0. So I'm going to put 0 in for h of t, and now I'm going to solve for t. In this type of equation, when your b value is 0, you can solve for t by doing the square root method. I'm going to subtract 70 from both sides, and then I'm going to have a negative 16t squared, and then now I'm going to divide my negative 16 on both sides. So I wind up with a t squared is equal to, and this is going to become a positive 70 over 16 because a negative divided by a negative is a positive. I don't have to reduce that because all I'm going to do is take the square root. So in my calculator, I'm going to do the square root of 70 divided by 16. and I'm going to round to the nearest hundredth like it says. This is approximately 2.09 seconds. That's when it's going to hit the ground. All right, next problem. We have during a halftime of a basketball game, a slingshot launches t-shirts into the crowd. A t-shirt is launched with initial upward velocity of 64 feet per second from 5 feet above court level. The t-shirt is eventually caught above the court, 35 feet above the court. We're going to round to the nearest hundredth whenever necessary. So we are launching this t-shirt into the crowd with an initial upward velocity. This means that this is the vertical motion model. So actually what's going to happen here is we're going to have the t-shirt being slung shot up into the crowd, and then it's going to come back down and be caught. So this is a parabola shape that we're dealing with. The equation would be h of t is equal to negative 16t squared plus your initial upward velocity times t plus where it started, which it started at 5 feet above court level. The direction of opening, since my a value is negative, is down. Now we want to figure out how long it will take the t-shirt to reach its maximum height. Now on this parabola, the maximum height is this point here, which is the vertex. And if we want how long it would reach the maximum height, that's technically the x value or the t value of my vertex, time. So time is the t value of my vertex, and the h is the y value of my vertex, which is my maximum height. So remember, to find the x value of your vertex, you do x is equal to negative b over 2a. In this situation, we don't have x, though, we have t. So I'm going to do t is equal to negative b over 2a. And in my equation, my negative b would be negative 64. And then 2 times my a value, which my a value is negative 16. So I really have a negative 64 over a negative 32, which when I do that division, I get 2 seconds. So now it's asking, what is the maximum height? So I know the x value of my vertex, or my t value here. To find my maximum height, I want the h value of my vertex. So I'm going to put 2 in for t into my original equation. And when I do that, the h of 2 just means that we're finding t when we have 2 seconds, so I don't need to worry about that. Instead, I'm just going to worry about this part here. So in my calculator, I have a 2 squared, which is a 4. A 4 times a negative 16, which is going to be a negative 64. And then I do plus 64 times 2, which gives me a 64. And then I do plus 5, which gives me a 69. So my maximum height is 69 feet, and that happens after 2 seconds. Then, if no one catches the t-shirt, how many seconds will pass before it comes back down to the ground? So ground is 0, which means the height would be 0. So I'm actually finding t for when my height is 0. Technically, what I'm finding here is my solution to this quadratic equation. So what we're going to do is we're going to use the quadratic formula. X is equal to the opposite of my b value plus or minus the square root of b squared, which is 64 squared, is a 4,096, minus 4 times my a value of negative 16 times my c value of 5. And this is all over 2 times my a value of negative 16. I'm now going to simplify, so I have a negative 64 plus or minus the square root of, and a 4,096 minus a 4 times a negative 16 times a 5 gives me a 4,416. And then this is all over 2 times a negative 16, which is a negative 32. I'm now going to put parentheses in the proper places, and I'm going to type this all in to figure out my answer. So I have parentheses, negative 64 plus the square root of 4,416, close our parentheses twice, and divided by negative 32. I'm going to round to the nearest hundred. This is approximately negative 0.08. Now I do that again, but I do a minus sign instead, and I get approximately 4.08. Now I cannot have a negative time, so I cannot have it be negative 0.08 seconds. Instead, my answer is going to be 4.808 seconds is when the t-shirt would reach back down to the ground if nobody caught it. All right, that brings us to the end of level 3.